in this video, I thought it would be quite interesting to try and do a vibe coding example. And by that, what I mean is we are going to use AI or machine learning, to be more exact, to generate a script for us, or a Python script to be more exact, which is going to do something constructive. Okay, so I thought it'd be quite interesting if we could take some pictures that I've taken with my phone of a park near the office. And I thought what we're trying to do is get a script or something written that would read the metadata on these images and convert the GPS coordinates to a point, and also extract the GPS direction bearing information, which is also on there, and turn that into an attribute which you can then use in n4ce to orientate like a symbol, like an arrow. So the idea is that we'd essentially use the script to select some images taken with a phone, and then the script will create points in n4ce, attach a suitable attribute to those points, which will then tell n4ce how to orientate a symbol, and then we'll automatically attach the image to it. So that's the plan. So to do that, I'm going to use a product called Google Antigravity. It's completely free to use. You will need a Google account to access the free tier for the AI side of things. But Antigravity is essentially a way of coding without actually having to get your hands dirty in terms of actually writing some code. Antigravity is a spin-off of VS Code. So to start, what we're going to do is I'm going to show you first of all is the website to go to. So here is the website to go to download and install Antigravity. Obviously, I'm doing this for Windows. n4ce is a Windows product, so unfortunately, it is only available in Windows. As I said, there are various tiers when it comes to using machine learning and AI. So if you are just using the free tier, you'll get a certain number of sort of tokens that you'll chew through quite quickly. And then there are various other tiers that you can go through. So depending how much you use it, you may have to obviously sign up to one of these schemes. So to get started, what I'm going to do is I'm going to open a folder which I've already got set up. My intention is to share this folder and the contents of the folder, so you could in theory, or should be able to in theory, repeat everything I do on your own. So when you open up Google Antigravity, I can't remember what the interface looks like. It should look like this. I've obviously been using it for a while now, so it might look slightly different, but it should look something like this. I'm going to click Open Folder, and then I'm going to pick the folder I want to use to start my vibe coding in. So I'm going to click Open Folder. Okay, so this is the folder I'm going to start in, and I'm just going to Select Folder. Now you may be asked at this stage if you trust the code in this folder. I've done this so many times, and I must have pressed a button that says always trust, but if it asks you about trusting this folder, you obviously need to say yes, and then it will continue. Okay, so in that folder, we have some files already. We have a template SDB file, which we'll be using in a second to actually test the output. We have a file called agents.md, which I'll come to in just a second, another one called n4ce interaction.md, which again I'll explain, and a subfolder with some images in, which we'll be using to test our output. So the first thing we need to look at then is this agents.md file. I didn't write the entire contents of this file. This is a file that I've got from watching other tutorials on YouTube. There are lots of tutorials on VS Code and lots of other tutorials on Antigravity. But the crux of it is that we need to instruct the AI or machine learning system on how to behave, how we want it to work. We have to almost give it a personality and give it strict guardrails so it doesn't go beyond its guardrails, and it does exactly what we tell it to do. It checks what it's going to do, and it validates what it's done, and it doesn't hallucinate. Okay. Now the other thing that I've also added to this section of this file at the top, where it says token minimization, is a section which will hopefully save you a bit of money, because if you're not careful, the AI, no matter whether you're using Gemini or Claude, and Claude is probably even worse than the others, in terms of the amount of tokens you use, it'll chew through them much faster. It'll send data it doesn't necessarily need to send, and it'll be overly conversational, which uses up tokens. So this here instructs it to essentially just stay in its lane, fundamentally. So what we're going to do is we're going to instruct the AI to instantiate this file, do everything this file tells it to do. It tells it to create some folders, and in essence, this file is going to tell it how to behave like a professional software engineer. And I'm going to copy and paste those instructions in now. So my instruction is read and instantiate the agents.md file, create all necessary files and folders, and I'm using the Gemini 3.1 Pro High model. You may have a little thing that says planning next to it. You want to turn that off because we don't want it to essentially create a planning document to do this. We already know we have our planning document. We just want it to act on that, so to speak. So I'm just going to hit that arrow button there, and it's going to go away and hopefully carry out our instructions to the letter. So it's analyzed the file. It's deciding what it needs to do. Okay, and now it's starting to create the folders and structures down the side here for us. Okay, so that has now finished, and it's created the folders as I said that it needs to, and it's now essentially awaiting for further input. All I'm going to do is press accept all, so that I'm happy. Basically, I'm confirming what it's done, and I'm happy that it's created the folders I asked it to. So you can see here it's basically saying it's awaiting our directives. So here is a second directive, and I'll paste that in now. So I'm telling it to read the n4ce interaction.md file, and this tells you, or tells it, how to interact with a Cadd platform called n4ce. So now we're giving it all the information it needs so that it knows how to interact with n4ce. That document contains everything it needs to know in terms of creating a little plugin and how it can pull information from the model and how it can put it back again. Now it's understood that document, we can now tell it what we want it to do. So I'm going to paste them into an empty Word document so it's easier to understand. The idea is that we want this AI to take these images, extract their metadata, create the points, and convert the lat and long into a coordinate system that's applicable to wherever you are in the world, and attach the image and give it an associated bearing attribute, so it'll actually draw an arrow in n4ce and point it in the right way. So this is not the first time I've done it. This will be about the third, so anything's possible because you don't always get exactly the same results. This prompt is very specific. It's the combination of about 4 or 5 attempts of doing this. So I'm going to read it through and try and explain the logic as we go. So we're basically saying add a new file called images to points.py, so that's the name of the add-in, or the name of the file, the Python file, to this project. In this file, write a Python script that will offer a user Windows dialog to select one or more JPEG files. Okay, so we're asking it to create an interface that allows us to pick the files. These images have been taken from a mobile phone. Each of these files contain metadata. Use the specific latitude field, which is a decimal format, and the specific longitude field, which is decimal format, to compute the UK ordnance grid coordinate for the file. So this is specifically going to work in the UK. If you are elsewhere in the world, then you will probably need to use a Python library called PyProj. Okay, so you would essentially tell it to use this library, and then you would use what's called EPSG numbers to tell it where you are in the world, and you would then ask it to essentially convert from the WGS84 and lat and long on the metadata to your appropriate EPSG zone. So for now, we are going to tell it to use the Python library OS grid converter, which is here, which is specifically targeting the UK. So that's why we're telling it to do that. And it's going to handle the conversion as accurately as possible. So that's very important, so it doesn't truncate any values. It keeps the data as accurate as possible. here we go. See, make sure no values are ever truncated. That's something I learned in a previous prompt. Always use maximum precision. Generate an n4ce model called image points and put in it an n4ce point for each image. Each point you make will be assigned the appropriate XY value calculated from your double GS84 to UK grid conversion. So I'm being very, very specific there. If you weren't doing this in UK and you were using EPSG numbers, you could ask it here, for instance, to actually prompt you, type in the EPSG number, or you could even give you a drop-down list, okay? So those are all things that are completely possible. You just have to tell it exactly what you want it to do. So carrying on. Also, extract the GPS image direction field from each image and add an attribute called B to the point and set it to that value of the GPS image direction field. So a B equals an n4ce is used to add, or rather used to set the bearing. If you're going to attach a symbol to that point, it will orientate it to that bearing. Then we're going to use the add image method, which is described in the n4ce interaction document, to assign the image to a point using the full path, and finally set the point code to IMG, because that's going to tally with the code I've already set up in the n4ce code table to do that. And then we're going to finally add the points to the n4ce model. We are also going to tell it to add a detailed logging system so that all the metadata we read from the images can be stored in this log file, and we're also going to add key details from our code so that if there are any issues with the application, it will be able to read the log file and decide where the bug or problem came from. And then we're going to export this to a log file in the same folder as the images. And be sure to close any and all file handles once the script completes its work. That's important because otherwise it never lets go of the log file and you won't be able to delete it. So we're going to copy this now, paste it in, and hit go. So we can see it going through its various thinking stages now. I'm going to fast forward this and then we will return back when it's finished its thinking. And this is the process that will actually chew through tokens if you're not careful. So this should still be possible on the free tier, but if it comes back and says you've used too many tokens, you might have to essentially hit carry on within say 24 hours and it will carry on. But I think this should all fit within the free tier. Okay, so that has finished. So I'm going to press accept all and we will just have a quick look at what it's done. So it says I've created the Python script. It's created the Windows dialog. It's using high precision EXIF data, and it's using the PIL library, so the pillow library to do that, which I'll come to in a second. The coordinate conversion is done via the OS grid converter library as we expected it to be. It's read how to integrate with n4ce, and it's using the appropriate fields from the images. So, and it's applying proper file handling. And it's given an example of that. So it says the tool is ready to be utilized in your n4ce workflow. Let me know if you would like me to test it or create a directive markdown file for it. So it's basically asking, would you like me to test it? It can't test it because it can't run n4ce, but it could commit the basic logic of this to a markdown. That might be something you might want to do in the future. You could ask it to create the markdown file and explain the logic to itself. So essentially the next time it fires up, what it would do is it could then read that markdown file and essentially bring itself up to speed so that it knows everything it knows now. But it's created the file. Now, if I go into the actual source code, so that'll be in a folder called execution, because that's where the markdown, the original agents.md file told it to put it. Here's the source code. And it's importing some files, it's importing at the top some libraries, so it's importing the OS grid converter and it's importing the PIL library. Now I will explain those in a moment, but essentially those are libraries that we'll have to download and install if they're not already downloaded and installed. Now these libraries must be installed before the script can run. I will show at the end of this tutorial how these scripts can be downloaded and installed, but we'll carry on just for now. So, testing. I'm going to open up n4ce now. Okay, so this is the template project I've got set up. It's basically just got a Cadd model with the image of the field I walked around correctly coordinated, and it's also got, if I go to code and I come down to the code that says IMG, it's just going to draw a point, and if I go to the symbol tab it's going to draw a arrow, and the arrow is orientated vertically. That's very important to begin with. Okay, and if I go to fields, I've got a default S value, which is going to scale it, and it's going to be 20 times its normal size, because its normal size is only 1 meter. So let's see what happens. So I need to click on the models folder. That's critical because it has to start under models, and then we're going to go to the plugins, and I'm going to go to run file. I'm going to go to select. So having selected models, I'm going to go up to here. Now I've already been running these, so I'm going to just show you how you would actually just select it for the first time. So if we go to select file, and then we go into the execution folder, here it is. Okay, that's today's date. That's just a few minutes ago. So we're going to press open, and the first thing it's going to do is what we expected it to do, is to ask us where are the images. So we'll go back a folder, go into sample images, and I'm going to go into this folder here, and these are the images I took with my phone on my first attempt. So press open. Okay, so it says 4 images have been imported, it's saved the log file, everything is good, hopefully anyway. So if I click on the model, you can see we've got some coordinates here for our points, obviously no height, and we've got the bearing information attached. So if I double click on that, to extent, we have something. So if I now click on the backcloth button, go to images, move that over. Right, so the directions aren't correct. The arrow should all be pointing inwards. If I hover over a point, though, you can see that that is actually that correct image. It's just not, the arrow is not pointing the right way. That's correct. That should have a flower bed on it, and that one's looking back. Yeah, so the actual images are correct, but the arrows are not. That one probably needs to rotate 90 degrees clockwise. That one would need to rotate 90 degrees anti-clockwise. This one would need to rotate 90 degrees clockwise, and this one would probably need to rotate at least 90 degrees anti-clockwise. So there's a bit of an inconsistency there. And it turns out, after an awful lot of testing, that there is actually a problem with stock Google Pixel camera apps. It can store the bearing incorrectly. It says minus 90 degrees there, but in my testing it can be plus or minus 90. So I'd wasted an awful lot of time trying to get this to work. It turns out the camera app isn't brilliant. Half of the battle sometimes is the debugging side of stuff. So if I open up the log file, okay, and here is the log file that was created. So you can see all the information in here. So it tells you the name of each image, and you can see we've got this angle here, this direction. This value here, this GPS direction reference M, means magnetic north. So we now know that there is a possible problem. So what we did was we went out and did it again, but we used an Apple phone. So if I rerun the same script and we go back and I run it with an iPhone and select these images, which are taken in exactly the same place. So let's just rename that one to Android Day 1, and we'll rename this one to iPhone. So we'll double click that and we'll zoom to extents, and as you can see, all the arrows seem to be pointing inwards, which is what they should be. If I go to images and move that over, press OK, and there we go. So the unfortunate truth of the matter is that the iPhone worked perfectly. Its positions and bearing information were absolutely spot on. So that was a bit annoying. After doing some more research, however, it turned out that there is an app for an Android phone called Open Camera, I think it is. So I downloaded and installed that. And let's give that a go. Okay, so it's done on a different day. Unfortunately, it wasn't quite such good weather. Okay, so image points. So let's call this one so I don't get confused. And Android Day 2. And double click that. Okay, so you can see now the arrows do look better. If I put the image back in, okay, so that's kind of what we were expecting. The arrows still don't look absolutely amazing, if I'm honest. Not great, but if I backcloth it with the Apple data, and let's just change that to say yellow. Okay, so the yellow arrows indicate where the iPhone think it was. Now, we were standing next to each other when we did this. For some reason, it's got that one perfect, and then it's drifted. So I guess that just shows the differences in GNSS on an iPhone and an Android. I would probably go with the Apple in this situation because things seem to be more consistent. But the proof is actually in the pudding. You can just take some pictures, load it in, and it kind of works. And we haven't had to write a line of code. The one thing that I do need to talk about, though, is the dependencies. Okay, so like I said here, we are relying on some libraries. So with normal Python development, you would use what's called pip to pip install these libraries. Now, n4ce ships with its own copy of Python. It's separate to the normal copies of Python that people may already have installed on their systems. We do that specifically so that we can get repeatable results. If you have varying copies and versions of Python on your computer, you could potentially get different results, especially using the different libraries of these other plugins or these other open plugins. So we ship a copy of n4ce with its own build of Python. So you can't just use pip install to do that. So what you need to do is you need to go and edit a file called requirements.txt. So here is that folder. It's our program folder called Python, and this is the file you need to edit, and you need to edit it with administrator privileges because it's running under program files. So to do that, you would actually open up a copy of Notepad, you would right click it, and then when it's running, you can just right click it again and choose run as administrator, and then you need to go and open the requirements.txt file, which is in this folder. Okay, so when you do that, you'll see a file like this. Now mine will be different to yours because I've already got some other projects I've been working on. And what you do is you then tell it what libraries and what version you need it to install. So this is the pillow library. Okay, so you would write something like this. So copy that just to be on the safe, and you paste it in, and then you do double equals, and then you type in the version number, which I will copy off screen and paste in. Okay, so that's the first one. And the other one is here. Okay, so that's OS grid converter. If I just take the whole thing, probably quicker, isn't it? So minimize that, new line, and then just backspace, and you need to do a double equals. Okay, and then you just go file and save. Once that's done, you need to run a small program that comes with n4ce, which will then read that file and do the installation for you. So we'll just do that now. Okay, so the file you need to run is called the Python module installer. And all you need to do is just press install. Once you've done that, it will download the necessary files and pop up a message to say it's done. Okay, so that's really all there is to it. You don't really need to do much more than give it a suitable prompt. If there is a problem, you then obviously have to give it the log file if there's been a crash, or if there's a problem with the output, you just describe what was wrong here. Down in the prompt down there, you tell it what was wrong, you press go, and it will go away and modify the file, and then you run the file again. And if it wasn't successful, you tell it why, and you keep on doing that. So that's what I did. So the prompt that I put in earlier to do this was a function of about 4 or 5 different attempts. So I had to tell it what library to use, I had to tell it to be very careful, maintaining its precision and all that kind of things. But then eventually it got there, and as you can see, it's worked quite well, and I haven't had to write a single line of code. Just to demonstrate another type of scenario, I have here a Cadd plan. Okay, now this was taken from a previous video I made on drawing up floor plans in n4ce. I thought it would be a good challenge to see if we could actually turn data that is essentially Cadd data and turn it back into XYZ point data so that we can then use the Python API to try and do something with it. So this data here is drawn all at the right level, but it's essentially a 2D kind of CAD plan with, or pseudo 2D, okay, so that these entities, these doors and window openings, or etc., all at the right height. So what I did first of all was I took this data and I used the n4ce tool where we can generate point data from Cadd information. So I generated it from elements, because when I do from elements, it'll do it from symbols and lines at the same time. So we have obviously symbols for the doors, symbols for the windows, and just basic line work for the walls. So I generated points and used some codes I'd set up. So for instance, the code for windows is set up so that it draws a 2-point scaled window between the 2 points. And obviously the window symbol in n4ce is set up so you have the origin there and the handle there. Likewise, if I were to click on a door, okay, that is also set up in exactly the same way, but just with a different symbol. The main change I had to make was for the walls, okay? So for the IFC file to correctly construct this geometry in 3D, you basically have to have an outer wall and an inner wall as your main construct for the start of the building, because the inner wall is going to cut itself into the outer wall to give you the essential shell of the building. And then everything else, all these internal walls, so if I was to go to query and get a query line, okay, that's a continuously closed feature. So that was the edits I had to make. So once I generated the points from the CAD data, I just had to make sure, or I had to re-edit the data because I hadn't drawn it up for this purpose. So I had to make sure that the outer walls will have their own codes. I use O walls for that. Okay, and the logic basically is that the odd number wall is cut into by the even number wall. Okay, so in the code, this will be extruded based on a variable up to the height of the building. Okay, and then all the other walls can then just be extruded themselves because they are a self-contained polygon. But these outer wall, for the outer wall to work, this feature has this feature cut into it, and then it's extruded up. Okay, everything else has an attribute on it to tell it the height of it. Okay, and that was an attribute I just created. So on these windows, you can see they have a height attribute. Okay, the doors as well, they have a height attribute. And to set those, I just basically went into here, I selected the attributes I needed to do, and I did dimension set, typed in what I wanted to call it, and set the value. Okay, and I just did that on the points that needed it. Okay, you notice the walls don't have a height because at the moment they're just using a global variable in the code. So what I then told the code to do, or what I then asked the AI to do, I should say, is read the model, okay, and using the codes you can see here as global variables, extract that from the model, and then build the IFC file. It did take a number of attempts, okay, and for anyone interested, I got the AI to update this directive here, so you can see what it's had to do. I'm not going to read it all out, but if you wanted to, you can obviously pause and read it yourself. And yeah, so it ultimately just takes that code now and generates the IFC file. There are basically infinite possibilities. All I had to do really was tell it what code library to use, because obviously there's lots of different libraries out there for different things. So I told it to use the appropriate library for generating, that's called IFC OpenShell. Told it to use that OpenShell library to generate and read IFC files. And the rest of it was just a process of elimination of generating the outer walls first, which is why I had this variable here for just walls. I got the outer wall to work first. And then once that was done, I could then ask it to then carry on and then start making the window cuts, or start making the holes for the windows and doors based on the attributes that you just saw a moment ago. Okay, so to see how that all plays out, I'm going to select the model I want to process, and I'm going to run the script. It says where do I want to save it, so it's just using the default name output for the time being, so I'm just going to overwrite the existing one. Okay, and that's all done. So then I'm going to double click that to view it. Okay, so here's the model data, and I'm going to go into 3D. Okay, so here it is with the point cloud on top. So if I just turn that off, we're back to just the vector work again. Now if I go to the Models tab, and then go to Import Scene and select that IFC. Okay, so we've got the Explorer view here, which allows us to navigate all the way down to the individual objects that we've output. So I'll close that for now, and I'll just hide the file name. Okay, and there we go. I've got the clipping box turned on, so let's just go to Point Cloud Tools and turn that off. We get the top of it. There we go. Okay, so there we go. So where we have a door opening, we have the correct size opening, we have a window opening to the correct height, and otherwise all the other windows have been formed exactly as per the line work. Just took a few seconds to process, but obviously a bit longer to vibe code. It probably took me a couple of hours to get it all working correctly. But yeah, it's all doable, it just takes a little bit of time. So if I switch back to the code now, chances are you may not be able to do that with just the free tier because it was quite a few attempts, especially if it's trial and error. But you know, you can do it. You just have to be patient if you run out of tokens on the free tier, because it'll just refresh in a couple of days maybe, and then you can have another go. Hopefully after watching this video you can vibe code your own tools and extend the functionality of n4ce to do whatever it is you want it to do. Cheers for now.